All right, folks, good day, everybody. This is lesson 2 of week 4. All right, we're actually going to be doing lesson 8 in the workbook, lesson 8 in unit 7 workbook today. All right, now, today we're talking about combining bases. Now, if y'all are familiar, y'all remember, okay? So, let's say we have this number 5 to the third power, okay? The 3 is the exponent, right? And the 5 is the base, right? So let's say we have 5 to the third times 2 to the third power, okay? So normally we would think, okay, we've got 2 exponents. Let's combine those. Let's use the power rule, add 3 and 3, and we'll get something to the 6th power. Well, here's the problem with that, is our bases are not the same. So we cannot just go combining them, all right? Or just like using the product rule. What we can do is this, okay? So 5 to the third power times 2 to the third power, that's same as saying, so we've got 3 5s times 3 2s, right? We could mix those around a bit. Okay, so let's say instead of ordering it this way, let's just erase this and do it this way. So we've got 5 times 2 times 5 times 2 times 5 times 2, right? So now we've still got 3 5s, we've still got 3 2s. So it's the same as 5 to the third power times 2 to the third power. We've just mixed up the order a little bit, okay? So what we've got now is 3 groups of 5 and 2, right? So we've got 5 times 2 to the third power, okay? Which, who can tell me what 5 times 2 is? Oh, nobody, because I'm talking to an iPad right now. But anyway, 5 times 2 is just 10. So this is going to be the same exact thing as 10 to the third power. Okay? Now this works here because the exponent's the same number. Okay, so there's the same number as 5s as there are 2s. So we can group those together and we'll be all right. Okay? But let's do an example where those exponents are different. Let's take a look at what that looks like. Let's see what that looks like, okay? So let's say we have 3 squared times 4 to the third power, all right? So here we can have, well, we'll have 2 3s and we've got to have 3 4s. Okay, so here we still have, we can have these 2 groups, okay, but this 4 is left out. You know, 4 doesn't like to be left out. But if we did this, well, 3 times 4 is 12. We've got 2 12s and a 4 left over. Okay, so we'd have, if we were trying to simplify this, we just get to 12 squared times 4, or 144 times 4. Okay, and that's not as, I mean, it's definitely not as nice as up here where we had just 10 to the third power. We could easily figure out this was 1,000. Here we still have to do a little more math. All right. So this rule doesn't really apply if the exponents are different. Okay, we can't really use this. And I'm not going to call it a rule because it's not really a rule. It's just how we can combine bases. Okay. But we can also do this in reverse. Let's say we have a problem like, well, let's say we start out with something that looks like this, okay? And we were trying to figure out what the exponents were on the original numbers, okay? So what these numbers were to start off with. So let's say we've got this. We've got this problem, 4 times 6 in parentheses to the 4th power times 3 times 4 to the 2nd power times 6 times 3. To the 3rd power. All right. So let's say we've got 3 different numbers here. We've got 4, we've got 6, and we've also got 3. Okay, so we've got 3 in there as well. Ooh, that was not good. Whatever, it looks fine. All right, so we've got 4 to a power. I don't like that color. Let's use this blue. 4 to some power times 6 to some power times 3 to, again, some power. Okay, we don't know what those powers are right now. But you know how I say, you know, when in doubt, write it out? This is like saying we've got four 4s and 4 6s right here. Okay? So where else do we see a 4? There's a 4 here, and we've got 2 of them right there. So if we add those, so we've got 4 4s here, and we've got 2 4s here. So that means in total, we're going to have 6 4s. Because 4 plus 2 is 6. That tells us, those exponents, remember, tell us how many of those numbers there are. All right? So let's try this again for the 6. And if you want to work ahead and see if you can do this before I kind of show you or tell you how to do it or what the answer is, feel free. All right, so for 6s, we've got a 6 here and a 6 here. Well, technically, we've got 4 6s here and 3 here. So how many 6s in total? What's 4 plus 3? If you wrote down 7 before I did, good work. Okay? Because we've got 7 6s in total. All right? Okay, so let's do this for the last one, 3. All right, we've got 2 3s here and 3 3s right here. What's 2 plus 3? Or how many 3s do we have in total in this whole problem? We've got 5. All right? So there you go. Now we know how many exponents there were to begin with. All right? Now see how if we were to combine all of these, we get something like that. That's a lot harder. Okay? But doing it in reverse and finding out what these exponents are, that's much easier. And there is a practice problem like that, like this in the homework. So if you want to refer back to this, you're totally welcome to. All right. So also in the book or on the website, if you are going on the website and clicking on the links to do activity 7.2 and 7.3, or sorry, this is 8. If you're working through and doing 8.2 and 8.3, you can click on that link and scroll down, and it'll show you the Lesson 8 summary. Okay? So if you want more help with that, there's the Lesson 8 summary in your workbook, online, or you can just slowly go through this notes video. All right? Great. So good work today, folks, and tune in for the next video. All right? Have a good one.